Hi, I'm Richard Endres. Today I'm going to give a video tutorial on this guy, the M362 high explosive mortar projectile. Now it also has a close brethren, the M370, which is white phosphorus, and that's going to look pretty much identical to this one. So the M362 was standardized in February 1955, which means it became the de facto mortar round of ammunition. In other words, replacing earlier World War II ammunition. So with the adoption of the M362 in 1955, it got rid of the concept of light and heavy high explosive mortar rounds. Now there was only one high explosive mortar round, and this was it. So before we go into the characteristics of this mortar round, let's talk about the patent that was applied for this round and the key takeaways that I got from the patent, because there were some major innovations that were brought forth with this mortar round, and we'll discuss those in just a couple seconds. Now the patent for the M362 was applied for in 1949 and was granted in 1954. And three of the key takeaways for me from this patent were, first of all, the streamlined body. So this body is completely smooth. There's no gas check bands. There's nothing. And that gave a much better ballistic shape to this particular mortar round as compared to previous World War II mortar rounds, the M43, M56, M57. Now the other key takeaway that they talk about in the patent is that the center of gravity is here at the bore leg, and the bore leg is right here. It also states that the center of pressure is behind the center of gravity. Now it doesn't define what the center of pressure is, but presumably it has to do with the propulsion of the mortar by the mortar propellant. So what it states, though, is that by having the center of propulsion behind the center of gravity, that reduces yaw. And if you're going to reduce yaw, which is spin on a vertical axis, if you do reduce yaw, you give better accuracy, better ballistic stability. Now the last thing that they mention in there has to do with the fin assembly. Now the fin assembly on this has an ignition cartridge up here. The cartridge container's way up here, and that may seem trivial, but let's go into what an ignition cartridge is, the cartridge container, and propellant increments, because this is a key takeaway for this particular mortar round. So this tail fin assembly is for an M43 series mortar, M43A1, M43A1B1. You can see my earlier video on the M43 series where I do talk about this. So the ignition cartridge basically looks like a shotgun shell. It'd have a brass face right here. This one still does have, this is from an M56 or M57. This still does have the remnants of the ignition cartridge, and it just looks like a brass shotgun shell. And there's a little primer in the very center. So what you do to fire the mortar is you drop the mortar down the mortar tube tail first, and what happens is there's a fixed firing pin, or a firing pin on the bottom, and that firing pin strikes this percussion primer. Then there's propellant inside this ignition cartridge. That flashes through these flash holes, which sets off additional propellant increments to send the mortar round downrange. on the M43 series, the propellant increment, you can see the flash holes here, the propellant increments are actually in between the fin blades. Alright, so what the M362 and M370 did was put a little tiny percussion primer here and put the ignition cartridge way up here. And as you can, the flash holes are actually way up here. And so the propellant increments go way up here, not way back by the fin blades. So what the patent states is that if you have the ignition cartridge in the very back here, and this being the cartridge container, the fin assembly is welded to the cartridge container. So what the patent states is that when the propellant ignites in the ignition cartridge, sometimes it causes the cartridge container to deform. If the cartridge container deforms, then the fins are obviously attached to that cartridge container. If the fins deform, it reduces the ballistic stability. And in this mortar round, it's the same thing, the M56 and M57. Here's the ignition cartridge here. So it would deform, this would be the cartridge container, it would deform this fin assembly if for any reason that ignition cartridge caused the cartridge container to deform. Now it also states, it was not true of the M56 and M57, this one right here, but it is true of this one. So it also states by having the propellant increments between the fin blades, it would sometimes lead to the fins being damaged. If the fins got damaged, then it reduced the ballistic stability. It reduced the accuracy of the mortar round. So with the M362, there's no propellant increments between the fin blades. The ignition cartridge is way up at the very front of the fin assembly, and the propellant increments go right in here. So to me, those are the three takeaways from the patent. Much more streamlined, smooth body. The center of pressure is ahead of, or is behind the center of gravity. And lastly, a fin assembly that does not lend itself to being damaged by the ignition cartridge or by the propellant increments. Next, we'll get into the characteristics of the M362 series and the M370. Okay, so the M362, as stated earlier, is a completely smooth body. There's no gas check bands, there's no groove for an operating band, that would come later, the M374 and M375. But not on this particular mortar round. There are other mortar rounds from the 1950s, for example, the 105mm mortar, that has the same kind of body, no gas check bands, no groove for an operating band. So this kind of a body is very much a 1950s era body. Alright, so the fuse well opening on the M362 and M370 is much larger than the earlier World War II era mortar rounds. Much bigger fuse well. Also, the body on the M362 is forged steel. The fins are aluminum. It's got a shrouded fin assembly like I stated earlier. The rear, where the percussion primer is much, much smaller than past mortar rounds from World War II. The flash holes are up much higher. And that is basically the characteristics of the M362 and M370. Now, I do want to contrast one thing on the fin assembly as compared to earlier fin assemblies from World War II mortars. On World War II mortars, they were threaded, and so they would thread inside to the mortar round. On the M362 and M370, Now the body itself has a threaded male assembly that screws into the female fin assembly, which is the opposite of what they did in World War II. So, M362. Now there was an M362A1. The only difference being the M362A1 was made from what's called PMI, Paralytic Malleable Iron. I hope I pronounced that first term correctly. The only difference, the reason they went with the PMI was, instead of forged steel, was much better fragmentation characteristics. So that's the M362 and the M362A1. Next, we'll talk about the M370. Okay, let's talk about the M370 white phosphorus mortar projectile. This obviously is still the M362, but the M370 is going to look almost identical. So the key difference, the key takeaway is that there was an adapter, press fit adapter, right about in here. That made the mortar round airtight. So you didn't have to worry about the white phosphorus being exposed, white phosphorus filler being exposed to air and starting to flame and to burn. And that's really the only key difference between the M362 series and the M370, is the existence of that adapter on the M370. Everything else is the same. Now, unlike the M362A1, there was no A1 version of the M370. Because it had such a tiny explosive charge and was really just meant to create a smoke screen or have a slight incendiary effect, there was no need to modify the body material to give better fragmentation. So there are no other iterations of the M370. There's only the M370. So with that, I'm concluded the M362 and the M370. And until next time, stay safe.